All right, and we're live. How's it going, everybody? Okay, so if you're joining in for the first time, I will be working on the Compose compiler today. And in particular, I'm working on an optimization that I've been pretty much streaming most of the work on, like since the start of the project, which was, like 2 or maybe 3 weeks ago or something. I'm not going to explain in high detail like everything that I'm working on, but if you're interested in kind of getting more context about what the goal of this particular task is and kind of the general plan for it, you can go back to episode 1 of this series. Hey, Alejandra. And I spend a good chunk of that first episode sort of explaining the thinking behind all of this and how we plan on doing it. Did I catch a cold? Do I seem stuffy or something? Or are you just saying because I have a sweater on? I feel fine, so I don't know. I don't have a cold as far as I'm aware. But my house has been freezing cold for the past few days. I don't know why. I guess poor insulation. Yes to which part? Are you just is it the sweater, or do I sound, now you have me like all worried I have like COVID or something? Well, I feel fine, but keep an eye on me. So, damn the lag. Yeah, I guess it's like a 10-second lag before you hear me talk and can respond. I wish that you could reduce that. I don't know. I wonder, because I'm using restream.io, I wonder if the lag is less if I streamed to Twitch directly. It would make sense if it was, or if I streamed to Twitch or YouTube directly. Okay, so let me show you all kind of what I've been working on. So basically here's an interesting test that I'm like kind of trying out. There's a few cases here. So in this case, we've got a composable function, B. B and V are going to be hard to differentiate with enunciation, but as far as I'm aware, I haven't been in contact with Trump. I make a strong effort not to be. What's up, Hackertronics? So we've got this composable function B, and it's got a type parameter V. So whatever the type parameter V takes on whatever type this value parameter is passed it. And then what I'm doing is I'm taking that value and I'm passing it into wrapper, which wrapper also has a type parameter T. And whatever value I pass into it, T has. And so the question then becomes, what is the stability of this expression here? And it's kind of interesting because we don't know anything about V at compile time, but we do have a runtime parameter which has the the type of V. And so because this is a composable function, we're going to have a metadata parameter that tells us the stability of that parameter. And so then the stability of this parameter becomes, or the stability of this argument becomes the stability of wrapper plus the stability of V, which is determined by the value parameter. And so what we can do is we can write something kind of like this. So this is what we're going for, where the stability is determined by wrapper.stable, and then we OR it with the dirty parameter, and we grab the stability bit from the first parameter index of B, and then that becomes the stability of this expression. And so this is currently what we're going for, and it doesn't do that right now, but that's sort of the logic that we're working on. And then here's like a similar thing where we have items, which is a list of string, and then we pass items into X, which X takes list of T, and then the composable children lambda is a composable of T to unit, which means that item here has type T, which in this case is going to be substituted for string, which is stable. So then the question is what do we pass in for these two arguments? So do we pass in stable for A, which we should because we know that the type is string? And then do we pass in stable for wrapper of item, which we should because, well, we should pass in wrapper.stable or item.stable, which is string.stable, which is known to be true. So these are kind of two useful cases for passing along the stability or propagating the stability through these like type parameters at runtime, but compiling the code to do that correctly at runtime. Hi Andre. And WMeet, hello, and hey Skycolor, good to see you. And Asher says, or has my wife come in contact with Trump recently, which I'm pretty sure she has not either. Zero Mod asks, what does the compose logo mean? Is there a specific reason for the logo? I don't think so. I mean, I don't know. I believe some marketing firm or something was retained to make that logo. It was unveiled to me. I played no part in its creation, so I have no idea. But I wouldn't read too much into it. Okay, so let's see what happens when we try and do this. Yeah, haven't come in contact with Melania either, as far as I'm aware. You know, but I suppose the White House wouldn't have told me if I had. So I'm just gonna debug this, and I kind of know there's some important places here that we're gonna break on. So what's interesting is this IR stable expression here. I added this resolve parameter, which basically whenever it runs into parameter-based stability, it will call this function, and it essentially wants the caller to take a type parameter and resolve it to an expression of stability or null. And so by default, it just returns null, which means that the whole expression will return null, and you know, thus it's not stable. But what we're doing is we're calling this IR type parameter stability function, which I wrote. Which what it does is it navigates up the scopes that we're in currently as we're transforming this IR. and it'll grab the composable scopes, and essentially it'll look through the value parameters to determine if one of the value parameters is of the same type of this parameter symbol. Can I smell stuff? Again, as far as I'm aware, I can. Let's see. Okay, so so here we are. What's the current expression? What are we doing right now? Okay, so meta is like the current parameter. So that's going to be part of this call here. So this is when we call A, which is, you know, what we want, I guess. This is probably the first call to A. Okay, and so the stability of this argument right now is the stability of wrapper plus the stability of the V parameter, which if we go to our test, that's kind of what we would expect. So what we want to do is we want to make sure that the parameter V stability gets substituted with the expression that pulls out the stability from this composable function B and its dirty or changed parameter. So that'll call this, which we can set a breakpoint here, and we should end up resolving that. So here we are. The type parameter is V, which we expect, and so then we're gonna go up to the function B. So when we're here, so this is a function scope. So the function here is B, which makes sense, and it has a dirty parameter. Okay. So one of these value parameters should show up, but so we're gonna end up here. So I'm gonna fast forward to that. So now it is a value parameter, and the type is a type parameter of V, and that's what we're looking for. So that's a good sign. And then our parameter param is type parameter V. So ideally these are the same thing, but so 9593 and then 10424. So they're not the same thing. The couch potato. So couch potato, as far as I'm aware, I'm fine. I feel fine, but everyone is conjecturing that I have a cold or something, which I then made the insinuation that it could be COVID. But as far as I'm aware, I'm fine. No need to be concerned. Okay, so these are different symbols, and I want to figure out why. Like we basically, so this equals check is gonna return false, but I don't want it to, because as far as I'm concerned, they're the same, but you can see the descriptors are different. So the descriptor here is a type param descriptor for V defined in B. But here it's a wrapped type parameter descriptor. So I wonder if the source element is the same, 10435. Yeah. So the source element's the same. This is the... Oh boy. What about moving a few protos? What do you mean by that? So it's weird that this descriptor, I mean, I kind of want to understand how to compare these two. I'm not sure if there's like a better way to compare two type parameters. So first, let's just get one of these. So I wonder if the signature, no, okay. That's not what we want. So we know the source element's going to be the same. But I don't want to use the descriptor. So I wonder, so we have param, and then what I want to get also is, or do we have it already? The classifier. Okay, so classifier dot owner. So I wonder if the parent field is the same, maybe. We're looking at parent or param.parent field. So 9596 9605. So even that's different. So this is function B. This is also function B. But this is the wrapped one, and this one is not. Oh, you know what? Well, shoot. Okay, let's see. We've got, I wonder if, so I have a symbol remapper. And I think, so if I do get reference classifier and I pass in symbol, so that's 9593, and then oops, get referenced classifier, and then I pass in classifier dot, or just classifier. All right. So that's still 10424. Ah, shoot. Okay. Get. What is, so I don't know the difference. I mean, get declared versus get referenced. Declared classifier? No. Oh, okay. Oh, type parameter. Interesting. So then here, if I did param that symbol, why did non-remapped symbol type parameter? Okay, so that symbol has not been remapped. Good to know, I suppose. Let's see. Get declared type parameter classifier as IR type parameter symbol. And this one also has not been remapped. I'm not sure what the right thing to do here is. These, I want these two parameter symbols to be connected to one another in some way, but I'm not sure what way that is. I mean, I suppose I can look at the source element, but that feels a little wrong, and I'm not even sure if I'm like, I don't know, allowed to look at it. The font size is blurred. Interesting. Yeah, here, let me just make the window a little bit smaller. I'm not sure. I think that'll help a bit. Yeah. Mahogany, let me know if that helped or not. So, all right. But the source element's only on, well, there's one here too as well, I think, right? Better, okay. So this is the type parameter. So I wonder if the parent, let's check this. So this is the, I want to get the param.parent, which that should be a function. And then should have an attribute owner ID. Let's see if this one has the same. So we would get classifier dot owner dot parent dot attribute owner ID. Function. So this will be an IR type parameter. Parent, and then this maybe needs to be an IR simple function. Yeah. Okay, 10308. Great. It's not even the same function. Hey, Abdelilah. So this is puzzling. I think this is happening because we're doing some kind of nasty stuff somewhere else. So So we have this type remapper. I want to understand what this is getting called with. So remap type abbreviation. Am I using that? Yeah. If we just take our small example, let's see what happens. So basically, there's this deep copy type remapper class, which we use in the backend because if you have a type, like let's say you have a type like this. So I declared a local variable, and it's a composable unit lambda. So in the eyes of the type system, this is just a unit lambda. But in the eyes of the compose compiler, this gets remapped into basically a composer, an int, to unit. And so we remap all of these types in the whole tree so that everything kind of continues to work out nicely. But I wonder if in the process is like if we had, you know, something like that and we map it to this, if like this t parameter is like getting recreated and for some reason like the symbols don't match up. That would maybe make sense to me. That like this is screwing it up somehow. So let's try and figure that out. So we're getting called. Can I like? I don't want these things. Okay. So unit, I don't care about. Interesting. So this is a type parameter, but where did? Oh, type dot arguments. Okay, so this is wrapper. Why didn't this get called though? That's weird. Oh, thank you. Thanks, Asher. I think you should be able to say, like, type in !womp, or there's like, maybe there's like some button or something on the right hand side of the like the player window. What? Oh my gosh, now everyone thinks I'm sick. Should I be worried? Okay, so we're remapping the type projection here, right? So this is just a simple type. Oh, but simple type implements type projection. All right. So what's going on here? Let me see. Type argument dot type is what? It's just itself. What does ASMR mean? I'm not like an audio person. Okay, so we're gonna end up calling remap type on this type parameter. Like, I wonder if something here should say if is type parameter or something. But I guess I should be referencing the, what does make type projection do? Okay, so let's like write some of these symbols down, I think. Well, so wrapper T we don't necessarily care about. So maybe we'll go to the next one. We care about the V's. So let's focus on that first. So I'm gonna stop that for now. Okay, so this is unit. All right, so here's a V. What are we remapping here? We're wrapper of V. Okay, that makes sense, I guess. Yeah, we're right. Okay. So what I want to find out is, so this is 9573 to start out. I'm gonna write some of these down. Or actually I can just mark it. How do I do that? Yeah, mark. So this is V from wrapper B. Sure. And so we're remapping the type argument. And I think, so we're gonna go into make type projection. Oh, oh no, we're calling this first, right? Yeah. All right. So now we're remapping V from wrapper V. And so we're gonna create a new simple type from that. And we're gonna get the reference classifier. Like I wanna see what this will return. So that's gonna return itself. Okay. Which is good, I think. And there are no arguments. What am I passing in null for? Kotlin type. Okay. I actually worry about that a little bit. I wonder if I should pass in the Kotlin type here. Anyway, I'll think about that later, I guess. Okay. So now we should end up in remap type or make type projection. And so this is the same V that we had. And I guess what I'm wondering, and what's variance here? So variance is nothing, and we're setting it to nothing. So I wonder if we shouldn't build, like it doesn't seem like this is doing anything. Well, okay, this isn't our function though. So I wonder, like, if the variance hasn't changed, then maybe we shouldn't do anything. Because if it's a simple type, then it is a type projection. Okay. What I want to do is I want to find out what's returned by this. Like, I just want to call this and see if it returns a type with the same symbol. As higher simple type. Right. So we get a new type, but the classifier is still the same. So the symbol that the type parameter points to hasn't changed. So this seems okay. All right. So let's go up. Up. Ooh. So this is my wrapper type that I've just Finished making. So that seems okay. So Abdelilah says, recently using Compose, my biggest complaint during development is that the preview's refresh rate is quite slow because it recompiles the whole project, which can be a bit annoying sometimes. My question is there some kind of incremental build to improve the preview's refresh speed when updating the UI? Or are there plans to create a compiler like that that just compiles the UI related stuff somehow? Yeah, basically, you know, best answer here is that, like, yes, currently the like iteration speed with the preview is quite slow if your project is of like any reasonable size, and we're currently working on a few different ways that we can make that a lot better, but they just, you know, these things just take time, and you know, we don't have anything to show on that just yet. But I agree it's a big problem and something that we need to work on. Let's see. So this is like kind of where a lot of this is happening. We've got a member access expression. So this and other, which is a constructor call. Which that's where the return type is gonna Yeah, no problem. And I mean, it is a very important topic. You know, this is one of the things that kind of makes or breaks a framework like this. So, you know, we're taking it very seriously. But yeah, it is currently a pain point for sure. So this is in get value. Okay, so this is the same V, which makes sense. So I mean, this all looks right. Like the V looks correct here. So I don't care about this anymore. So now this is T. Where did this come from? This came from the iterator. Okay. You know, maybe I kind of know what it is. So when are we running this deep copy? So create copier, deep copy. So let's figure this out. So if we go into the param transformer, so type remapper is this. So is this where we are right now? We are interesting. Okay, so we do a symbol remapper after we change all of the function signatures. And then we do a type remapper. So this collects all of the symbols. And then what I want to find is like when we create we basically duplicate composable functions. So we copy the type parameters here. Okay, I don't know. Let's go back to where we were. So we're here, we run into a T. Another T. Another T. What I'm looking for is a V. This is like all the any super types, I guess. So this is a type abbreviation. What's the type alias? Oh, all right. C lambda, whatever. It's fine. Oh, these are all. So that's where all these came from. Okay, so that was in mapping the composable lambda function. Star projection. Hey, Sean. Okay, so we made it through all of the type remapping. So now when we make it here, we should get a parameter v, but it'll be an unremapped one. Oh, thanks, Rashawn. Nice to hear that. So let's go down into here. And in this case, so the parameter is the same v from wrapper v symbol that we had. But when we make it here, so now the question is the value parameter has a type, and this symbol came from nowhere. Like, what is that? So this is where this came from, I guess, is the problem. Rashawn asks, so what's up? So right now we're trying to figure out how to get, like, basically we have two type parameter symbols that are pointing to basically the same thing. Like, we've got type parameter named v. It's on the function b. It's like where it came from. But for some reason, they aren't the same type parameter. So this is also type parameter name v. And it's defined on b. And this one is a wrapped value parameter descriptor. And its type is also so the type is also a wrapped type parameter descriptor. I almost want to like find out. So if I go to wrapped type parameter descriptor, I might be able to just like put a breakpoint there and just find out who is constructing this thing. So let me open up wrapped. Wrapped descriptors stack AT. Okay. Collapse all. So we're looking for this wrapped type parameter descriptor. So this constructor is going to get called at some point, and I want to know when. So let's do that. We can unset these breakpoints. All right, so here's where it's getting built. Declaration builders. I mean, we don't know if this is the problem one, but this is at least where it's getting, one place where it's getting called. So this is in, you know, generate files, whatever. Okay. So this is T. Also T. I can't tell if I'm ever moving forward here. Okay, this is R. What do generate files internal? Oh, I see. So this is, yeah, this is building like some of the intrinsic symbols and stuff. So as long as JVM symbols is in the stack, I can just kind of ignore it. Okay, so we're somewhere else now. What is this? Shared variables manager. I don't know what it is that it's building here. Like, so that's T. And then this is object ref. Okay, so we don't care about that. P1, don't care about that. So what are they? Okay, function 2. So this is like, you know, all these like built-in symbols. Function 2, don't care. What? Okay, so did we make it all the way here? So this is the call to A. Well, that's okay, that's weird. So I wonder if it's called lazily. Okay, because that's a little bit weird. So I mean, this type parameter descriptor now exists, but as far as I'm aware, we didn't ever see it get created. So that is weird. So this has a source element, right? Okay, like what I want to do here, I almost want to say source element dot, so let's see what, so now classifier dot dot descriptor dot source element. Nope, that's not what I wanted. PSI dot text. Okay, so what I want to do is when this gets created, if the PSI dot text, what? Oh, if it's a Kotlin source element, that's what we want. Okay. So we want source element as Kotlin source element. I don't know if you can see, yeah, you can see this, okay. So then we say, if the PSI text is equal to V, then we want to break. So great. Let's now run with that and see if we can catch this descriptor getting created. So Rashan says you can use the step into feature of the debugger. I'm not sure exactly what you mean. I guess like what I'm trying to figure out is when the wrap type parameter gets created for the first time. Like what I'm seeing is in my code, 2 of these type parameters exist and one has a wrap type parameter descriptor and one doesn't. And so I want to find out if my code is creating this wrap type descriptor somewhere. Would you like to, yeah, okay. Well, that didn't work. Can I not do that? I guess maybe I break here, source element as Kotlin source element. Maybe I can do that. Okay, that didn't work. This isn't my class, so I can't add an initializer here. But interesting, I didn't realize that a type parameter was a callable descriptor. I mean, does anyone see a good way to set a breakpoint here? It's kind of frustrating. Like, I don't know. I don't know if I've tried to break on a constructor parameter before, but maybe doing it on this line will help. So, I mean, it says this is invalid. So I'm not sure that that's... Let me try and rerun it. I mean, one thing I can do is like see if I can find... I mean, they shouldn't really be subclassing this. Or, I mean, it's clear from the debugger that they're not subclassing it, so... So I guess it could be called here. What is this? Kotlin IR linker. Interesting. Okay. This could be it, right? What is the... So, symbol type parameter v. Okay, so this seems like it. Okay, this is happening here. I wonder if I should write my own function that does this. So it says copy to without super types. And then so I wonder if there's a good reason to do this. All right, let's try tweaking this code. So basically we found the spot. So I'm gonna remove all these breakpoints now. There's too many of them. Okay. So let's like maybe write our own here. So fn's the new function. Can I? It is settable, right? Yeah, okay. So I'll just say this dot type parameters. Like, so I wonder, the old function, So doing something just really silly. I wonder if I just set the parents here, if that will like kind of work. All right. I think that may not be safe in general, but let's just see if it like, I don't know, like where it freaks out if it does. And let's continue to bugging it. I want to put, I want to set a breakpoint again here. And we'll see what that is like. Like, what are these other, so, gosh, I mean, so all of these copy functions create these wrapped descriptors. So I wonder if I need to create a wrap descriptor, but it seems weird to me that the, I guess what's happening is we're wrapping these parameters, but we're not like resetting them back when they're used in the body. So for instance, like what do I do here? So okay, well, interesting. So it made it here. Let's see what it says. So in this case, we've got param.symbol, which is 9496, and classifier, which is 9496. So this works now. I mean, this part of it works. We might have broken something else. But let's just see, I mean, let's just keep going and see what it does. So we go to our tests. That wasn't what I was looking for. Debug. Okay. Interesting. So this worked. Kind of. Okay, so the result of this test was that this line was this, which is what we wanted. So this is exactly right. This is working now. Did these other things work? So what did we receive here? So in this case, item was correct. Yeah. Interesting that is that right? Hold on. Composable lambda. Yeah, okay, it is right. Oops. Okay, so this looks correct. We're basically calling A and we're saying that you know, the stability of whatever's passed in is what we're looking for here. However, this is a little bit odd because we're transferring our comparison knowledge of dirty here, but actually the stability knowledge we have of item is better in this outer scope. So I don't know, we may want to do some work to try and improve that. What's happening here isn't wrong necessarily, it's just it's not leveraging all of the information. And then here we're what are we expecting here? So this now is right, because we have, so the stability of this is the stability of wrapper plus the stability of item, and item we know is string, and string we know at compile time is stable, and that's what 0 is. So we say or is 0. Now this or 0 is useless because, you know, oring an int with 0 doesn't do anything. It's but that's sort of just how the code generation is working right now. And so on the one hand, like R8 would probably optimize this away without any issues. But we might also want to just do a little bit of work to eliminate this in the first place. Okay, so overall, I mean, this is great if we didn't break everything, you know, doing this this type parameter thing, which we'll have to run some other tests to see if we did. But if not, then I don't know. It's at least a good start. So this is the sort of suspect code. Oh, although I'm still doing this copy type parameters from thing. Well, but I guess that's, I mean, that's now getting like overridden. So I think it should work the same if I do that. And then, I mean, this type parameter stability function, we might be able to do some stuff to improve the performance of this. I mean, what this is doing is it's going up scopes until it runs into composable functions. And then when it does, it's looping through each parameter. That's probably not a big deal because right now, I mean, well, it will go up all of the lambda scopes and everything. So, but I mean, the nestedness of this shouldn't be super high. We're only calling it when there's a type parameter. And then, I mean, so another thing that I could do here, I think this would be fine. But so if I said so basically and type parameters is not empty, because I think if the function doesn't have any type parameters, then this isn't ever going to be true. So we'll just kind of float up the scopes here, and we'll end up hitting scopes that we'll hit scopes that have type parameters, and then we'll check their value parameters to see if any of the value parameters match that type parameter. So, I mean, there could be some pathological code that would make this pretty slow, but I think in general, it's going to be negligible. So I think I'm okay with it for now. Okay. So that's neat. So one of the things that I wanted to do was to make some nice testing utilities here. Like right now, I think, you know, testing the stability transform this way is a little bit, I don't know, it's not great because it's good to do this for a few tests, but there's not a very high signal to noise ratio here. There's a lot of code that ends up in this test that has nothing to do with the stability, which is what we're testing. And so what I was wanting to do is to set up a test kind of like this, where we have 3 strings. So this string is allows us to use some code in some external module, and then this is some code in this module. And actually, this isn't just some code. This is specifically a class in the current module. And then what we return is the toString of the stability of that class. And so that seems like a nice way for us to test a number of things. And we could have another overload which had basically the same, you know, code in an external module, code in the local module, which could be anything, and then an arbitrary expression where then the last string is the stability of that expression. And so with these 2 testing utilities, I think that we could write quite a few unit tests and have like it be somewhat readable and like, you know, high signal to noise ratio here. So I'm gonna try and make those testing utilities. All right, so let's just start with this one, I guess. This will be similar to like our verify cross-module transform thing. Okay. And then I'm gonna see source. I'm actually gonna keep it this name, but oops. Add the dependent or external source here. And I'm going to import, well, first I'm going to give it a package. or let's just call it dependency, or yeah, dependency. And then I'm going to import a few things so that we can use it more easily. So mutable state of, since we might want to use mutable state of delegates in some cases. Get value and set value we'll add. And then let's go ahead and add composable just in case we need that. We'll also add stable and maybe state is useful there. And that might be enough, so we'll start off with that. And then I'm just going to make that protected. So now this is the verify compose IR transform. So we're going to do a similar thing here. I'm going to not do any of this regex replace stuff right now. Start equals actual performed. Okay, so let's do that. I'm not sure we need this extra file here. So and then here we're gonna, like, the idea is that we'll write a class definition and before this I might do a few things as well. So for one, I'm gonna import everything from here. So I'll do import dependency.star, and then I'm gonna import basically all of the same stuff. And then because this is just at like the end of the file, what I'm gonna do is like basically we're generating this IR module, and I'm gonna traverse through it and find the class, or the last class in that file. Last file, last class. So we'll just say IR module dot files dot last dot declarations, or let's see if we do declarations dot last. And actually, I'm not sure that I want to do that because we might inject like a live literals class that'll be after that. So actually, I guess it'll be the first index, the first class, because I mean there's also nothing above here. So first will work fine. equals IR class. So that works. And then type equals IR class dot default type. So here's what I want to do. So I want to get the stability of, oh, interesting, because this, so I don't have access to stability of because of because it's part of the abstract compose lowering. And where do I create our extension? Do I see that here? This processing step. Oh, I guess. It's this. Oops. No, it's not that. So I have an open function, right? Yeah, post-processing step. Find usages. So that's where I do that. But I'm okay. Oh, here's the extension. I see. Okay. So I might need to define it. Well, so we have the extension. I mean, the thing is our all right, I'm gonna create a new subclass that like saves some of this. Is that the right thing to do? Like, I mean, I could create another one of these. That's a little bit weird. Function body transformer. I mean, it'll work, but it feels fragile. Let's just try though. Compose function body transformer. All right, I mean, this is kind of gross, I guess. Transformer. Actually, I mean, this is kind of gross, but so I could just do that. Then context equals this. I mean, I guess, you know, one of the things we should consider whether or not we want to use a binding trace at all. I mean, I guess obviously we don't. Right now I'm using it to like memoize some things. Generates the symbol remapper and everything. Yeah, we shouldn't use it. We shouldn't do it this way. Like what I'm trying to do is to have all like the combination of all of these transformers. I don't want to have to define that in two places. So I'm trying to not do that here. So the problem is that like these stability of functions that we've defined are not pure. They require, well, really they're only using this binding trace. So I mean, maybe we should try and change that because they're using this memoize concept, which maybe that's like maybe that's the silly thing that we're doing here. So stability of Let's see. So let's make a new file that's adjacent here. New Kotlin file, and let's just call it stability of. And let's move all these implementations over there. So I'll bring Memoize with me. So I think as static, we're gonna want to keep, but we should be able to bring stability. So we moved those, and let's just get rid of Memoize. Well, there's the has stable annotation. All right. Not 100% sure we can do this, but let's give it a shot. All right. So that one's fine. That one's fine. And so this isn't even implemented. So basically we need has stable annotation is the thing. And then this one. We'll turn this into a return. So stability param bit mask. So these two things we'll want to move. And then the built-in int type. Let's see, okay. So maybe that's easy enough. Like, so we can turn this into so let's just say that we have a stability inferencer. And then the only thing that we need from it is the int type. Actually, where is this used? So find usage. I see, this is when we return. Yeah. Okay. But we could remove that. Because that could be done with the uncertain thing here. So why don't we do that? Because where is that used? So stable field here. is done here, and so we can change this. So here we can say val stable field equals declaration that make basically this. All right. So what that does then is that makes it so that this is never used. So we can get rid of that. Oops. And then we can remove it here. As well as here. And so by doing that, we got rid of this this function. And so then all we need is the stability param bit mask and the has stable annotation. So let's grab that. And the stability param bit mask, which is here. Nice. I wonder if we can do this without the descriptor here. I can fix that later. Okay, so with this, we don't actually need this class, so we can get rid of that again. And now these stability of functions are static, which is nice. I like that a lot. Which means that I can get rid of them here. Okay, so get rid of that. And that. Now, is memoize used somewhere? Where is that used? The usage. I see, they use each other. Okay, so we can remove this, I think, as well. So that's really nice. And then we'll clean up some of our unused imports here. And we might want to move that to this stability class file. That might be like a good place for all of this. So let's go ahead and do that. these imports to that file. Okay, now I can delete this. Delete. So, you know, this file kind of neatly becomes all things stability related. We might even be able to make these, we might be able to make these constructors private, which would be nice as well. So what that means is that what we were trying to do earlier can be a lot easier. So now that we've got this IR class here, now we can just import stability of, and we're golden. So now this stability string, stability, now we can say assert equals, and the expected will be stability, and the actual is going to be class stability to string. So that's pretty nice. All right, so that's our first test utility. And we can build our second one now, which is going to be a lot like our first, but what I'm going to do is, let's just say build module, and this will give us an IR module fragment. And that's going to be everything up to here. So let's just say that has an external source, class def source, here. So we'll say external source and local source. Whoops. So this becomes external, and this is local. And then we'll return this. Programador says, hey Leland, how are you doing? I'm just here listening because compiler is more complex than compose. Where's the dog? Had it show up. So the dog currently is at a doggy daycare type situation until like 2 p.m. or something. So we are free from dog duties at the moment. I'm thinking I might stream more this afternoon, maybe continue the code review that I started the other day. And if I do that, then maybe the dog will be hanging out in my room. Thanks for asking though. IR module equals build, say external source, class def source. All right, so that's good. And then here what we want to do, so this is sort of the trick that we'll play, I guess, is for the local source, we're gonna have all of that, and then what we'll do is we'll create a test function. Should it be composable? I don't think so. Function, and then here we'll just put the expression, and that way we can write like an arbitrary expression here, and then we should be able to get it back. Let's see how that works. So then what we do is in the IR class, we can so we can do this to get the last file first declaration, which that should be the class, but we don't really care about the class anymore. So first, so it.name, interesting. So let's say it is IR filter So what I want is the test function here. Filter instance. So let's say filter is instance to IR simple function. Can I do that? Yeah, okay. And then I'm gonna say the first one where the name identifier, I think that should be all right. Let's just say as string equals test function. So that'll get us our test function. And then well, actually, we really only care about the expression here. So what I'll do is I'll get the body of that. I mean, this is a test, so like if the body isn't there, then something went wrong. So we've got the body, which is an IR body. Okay. Dot. I guess one thing we can do is we can just say equals that. And then here we can say IR expression body. And here, do I have to put parentheses around this? That's kind of annoying. So I'll do that, and then I'll say dot expression. And that should be enough. So then I'll say IR expression. And then this is the expression stability. And then that'll be our second test, which I think that should work. So let's go ahead and run these tests and see what happens. I'm not really sure. Oh, all right. I guess we got to import this in several places. I guess just that. Let's try that now. Okay, still some imports we need to do. So I guess we imported it there. I don't remember that. Okay. And here. What's wrong? Dump classes. Oh, okay. We should go ahead and add that. Dump classes. We sort of add this to all of our tests. And we probably should here as well. So do that, and then build module, dump classes. All right. Looks like we got a bit further, so it's actually running now. Oh, I forgot to... I didn't end up needing to change anything here, so there's no reason to do this. So what this will do, if we have these two like testing utilities kind of working, is I should be able to create, you know, single tests verifying like a wide array of corner cases, which is the goal here. You know, this is a pretty significant feature for the compiler. It's gonna be doing a lot of work. It'll be changing a lot of actual behavior at runtime, and you know, I want to make sure that we properly test it before rolling it out. And so it's, you know, it's usually I find it really helpful to create kind of utility helper methods like this to just make a lot of the testing just a lot easier to handle. So it looks like that one passed. I'm a little bit suspect. So like if we just, you know, add some stuff here, let's like make sure that it fails. Never trust a passing test unless you've seen a failing one. Okay. So it looks like that is indeed working. Now let's try this other one. And so the kind of trick here is that bar is local. So the stability of bar is certain. Well, it itself is only the stability of T, and so we shouldn't actually see the stability of bar show up here. All right, so this didn't quite work. And the reason is that block body cannot be cast to expression body. Okay. So it was a block body, which is surprising given that it looks like this. So I'm wondering if it's like the wrong one or something. So this function should be constructing a bar with the foo passed in. Let's just go ahead and, you know, add a breakpoint there. I don't remember, maybe I didn't hit debug. That's failing before I can set a breakpoint. Maybe set a breakpoint here instead. Okay, so let's say IR module dot files dot last dot declarations. Let's just see what that shows up as. We have two, which makes sense. One's an IR class, one's an IR function. This will be an IR simple function, and the body is a block body. Interesting. I don't know why. Statements. Yeah, I don't know why it turned it into a block body here. Whatever. That's okay. I guess we'll wanna change this. So we can just say, so this is the IR test function, and then here we'll say IR expression equals IR test function dot body dot statements, yeah, dot last and so in this case the last statement is going to be a return, which we don't really want, so I guess we'll unwrap it. Let's just say that statements last, so that's a statement. Let's just say val last statement, and we will say equals when last statement is IR return last statement dot value else Selfish Coder asks, which Google campus are you working? Well, right now, obviously, I'm working from home, but when I do work in the office, I work in the Mountain View campus. So like, you know, the main Googleplex area. So if it's not an IR return, is our expression. Okay, then otherwise we're gonna couldn't, or let's just say unexpected statement last statement. Okay, and so now we have the expression, and then we get the stability of that expression, and then we test it. So this I think should work. Selfish Coder says, I recently got a job offer at the Mountain View office. However, I live in Turkey and I need to relocate. I'm concerned about relocating. Well, first of all, congratulations on the job offer. Yeah, I can understand some concerns about relocating. What are your concerns specifically? Maybe I can answer some questions or something. So this worked now. We've got the right stability of this expression, which is cool. So now these both work. So this is going to be really helpful for us. Philip says, isn't it better to use the assert that blank is equal to is equal sometimes leads to mismatches? I mean, so I don't think we're gonna have much of an issue here. I mean, so this is an overload of assert equals that expects strings, and you know, I'm not too worried about string equality producing unexpected results. So I don't know. Maybe there's something I'm missing. I'm not sure, but it doesn't seem concerning to me. So, okay. What do we want to do now? One thing we might try doing is just executing the full test suite and seeing what happens. I am curious to see if the changes that we made in the param transform, where is that? So basically we made these changes here, and I'm not sure that that's a safe thing to do, and I'd be interested in seeing if all of our tests pass despite doing that. We might have some test failures that are unrelated. They're like more related to some of the stability stuff that I'm doing, but that might be an interesting, just starting that process of, you know, getting all of our tests to pass. Like I think we're actually pretty close to that state where we can get all of the tests to pass that previously passed, and then we can start chipping away on some stability tests that aren't there. Okay, so Selfish Coder says, I've heard that rents are too expensive. Yeah, I mean, definitely the cost of living here is outrageous. But right now, for renters in particular, if you are looking to rent in the Bay Area, I think it's probably the best buyer's market, like for renters, that we've seen in a long time, at least from my understanding. So if you move now there, I mean, you might actually get a decent deal for Bay Area standards. It'll still probably be much more expensive than you're used to. I'm just guessing, just because it's one of the most expensive areas in the world. And so, I mean, you're definitely, like, I don't want to ask you like the specifics of your offer or anything, but you definitely want to weigh that in with the offer. And like, you know, you can get, like, I think in the Bay Area, and especially with companies like Google and, you know, Facebook and stuff like that, you can get compensation that is pretty ridiculous. Like it's pretty solid compensation, but if you're not from the area, it'll look even more ridiculous than it actually is, because you know, definitely part of that is the cost of living out here. And so you'll want to try and, you know, figure out exactly how much you'd be paying and like what that difference is in cost of living, and if if based on your compensation package, if that ends up making sense. And if you wanted to, reach out to me privately or something, then I'd be happy to, talk some details or something with you if that was something that you were interested in. But either way, I mean, congratulations on the job offer, and I hope it works out. But it definitely makes sure it makes sense financially for you if this is something that you wanted to do. So actually, I think on that note, I'm gonna go grab some lunch. This was a good stream. I feel like we made some progress. That type parameter issue was pretty iffy. So I might, it's Friday. I don't typically have many meetings on Friday, so I might hop on the live stream again later this afternoon, either to continue working on this or to do more of the code review that we started the other day. So if you're interested in that, look out for me hopping online. And otherwise, thank you for stopping by. And Selfish Coder. So if you want to, I'm trying to think of the best way to reach out to me, but if you want to just shoot me a tweet, at IntelligiBabble is my Twitter username, and shoot me a tweet, then we can hop on DMs or something and set something else up if you want to talk more about it. So anyway, thanks everyone, and I will chat with all of you later. Cheers.